Welcome to this video on the key characteristics of quadratic graphs. By the end of this video, you should be able to identify and apply all key characteristics for quadratic graphs. So this is what we've been doing for several days now. We are adding a couple characteristics in, so make sure you have a colored pencil or a marker or something to help you visualize some of this that we'll be looking at. Okay, so let's take a look at the first problem. I've already got these graphed for you, so you don't have to worry about graphing. We're just going to be answering the questions. So I asked a bunch of different questions. Notice that this equation is in vertex form, so we can actually answer the vertex quickly, or we can come over here and we can identify the points. So the most important points that people talk about are the vertex, the x-intercepts, and the y-intercept. So for our x-intercept, this is at -5, 0, and at -1, 0. If you have trouble seeing these, you can always put this into Desmos and take a look at it so you can scroll around and highlight what you want to highlight yourself. The vertex from vertex form is -3, -4, and you'll notice it is at -3, -4. Our range, the entire graph is above the vertex, so all of your y values are going to be greater than or equal to the y value of the vertex, which is -4. And our y-intercept, sometimes it can be a little hard to see. This one is at 0.5. So you can always put it in Desmos to take a look. You can look at the table of values where x is 0. Either one can help you with that. So our y-intercept is 0.5. And then I'm adding some stuff in. We've talked about one of these, end behavior, before, but then we'll also talk about intervals of increase and decrease. I want to start with the axis of symmetry first. Remember, the axis of symmetry is the vertical line that goes straight through the center of the parabola, right through the vertex. And we'll name it x equals, because that's how you name vertical lines, and x will be equal -3. Okay, so let's do our end behavior first. End behavior talks about the left-hand side and the right-hand side of the graph. This sentence says, as x approaches positive infinity. Well, x's are positive on the right. So they're saying as the x's get bigger, what are the y values doing? Notice this y value is going up, so that means it's going up towards positive infinity. So as the x's get bigger, y is getting bigger also and going up towards positive infinity. What makes quadratics nice about our end behaviors, if I asked you about the other side of the graph and said as the x's are getting smaller, what are the y values doing? They are also going up because the arms of the parabola both go in the same direction. The answer to the end behavior will be going in the same direction. So our answer to our end behavior is always either positive infinity because they're going up, or when we get down here, negative infinity because they're going down. So that's end behavior. It's a lot simpler than, say, an exponential function where you have to talk about the asymptote and everything. But our intervals of increase and decrease. So let's take a look at what I'm talking about here. All right, let's just take a look. I'm going to color half of this graph from the axis of symmetry out. I'm going to color this side pink to kind of help us see this side. And I'm going to color the other side green. Colors mean nothing. It's just to kind of highlight to help us see what we're looking at here. So when we're looking at our graph, we can see, as you read your graph from left to right, this green section is going down as it's going from left to right until it hits the vertex. At the vertex, the graph turns around and it starts going up. Those are our intervals of increase and decrease. So this pink side is going up, so that would be an increase side. The green side is going down as you read from left to right. That's your decrease side. And where they change direction is at the vertex. So our intervals of increase and decrease refer to an x value. And we said that our axis of symmetry is x equals -3. Okay? So let's take a look what the question actually asks. What is the interval of decrease? So they're talking about this green side because that's the side that's going down. Any x value that's to the left of the axis of symmetry is decreasing or going down. So we'll say any x value that's less than or equal to the axis of symmetry, because this left side of the graph is going down. If I asked for the interval of increase, that would have been any x value to the right of the axis of symmetry, because that's that pink section where it's going up. So you would have said the x value is greater than or equal to -3. And sometimes you might not see the equal to under. They might just have a less than or a greater than. It depends on, it can go back and forth. So just understand you might see it both ways. Okay, so let's try that again. We're going to go with problem number 2. We're going to start with our intervals first. So I'm going to sketch in my axis of symmetry to help me see it. Okay, and that axis of symmetry is, well, we'll name the vertex that will help us. -4, -1. So this axis of symmetry is at -4. Okay. On the right hand side, I'm going up as I read from left to right. See how it is, the graph is going up. So that's your increase size. On the right hand side of the axis of symmetry, that's where we're going down. Remember, we're always reading from left to right, so you would be going down on that left hand side. So that's our decrease side. Okay, now let's look. Our interval of increase, we're talking about the pink section because that's the part that's going up. That's to the right of the axis of symmetry. So that means any value that's more than -4 will be on the increase side. So we'll say any x that is greater than, we'll write it the other way so you can see it can be written either way. X is greater than -4. Okay? Now let's look at our end behavior. End behavior is easier. This says as x approaches -infinity. That means the left side x's. So as your x's get smaller, what are your y values doing? See how your y values are going up? So your y's will approach +infinity. If I had asked as x's approach +infinity, that would have been as the x values get bigger, what are your y values doing? They're also going up because the arms of the parabola go in the same direction. Okay, so let's take a look at this and see if we can identify some of these other characteristics. A solution is the same as an x-intercept. Solutions, roots, zeros, x-intercepts all mean the same thing. So we cross the x-axis twice, here and here. So we are crossing the x-axis at -5, 0 and at -3, 0. You're just naming the 2 points. Your range, the graph is above the vertex, so that makes it a greater than situation. And the y value of the vertex is -1, so all the y values on the graph are greater than or equal to -1. Our y-intercept is where the graph crosses or touches the y-axis. We cannot see it here. So your choice is, you can go put this in Desmos and look at the graph on Desmos. You can look at the table, put the equation into Desmos and look at the table of value where x is 0, because x is always 0 at the y-intercept. That's the part we know. And another way we can do this in our heads is we can substitute 0 in for x and say 0 plus 4 is 4. 4 squared is 16 minus 1 is 15. So there's multiple ways we can go about getting that, but there's always a y-intercept. So even if you can't see it, it's still there. For max and min, we're talking about is the vertex the highest point or the lowest point. In this case, it's on the bottom, so it's the lowest point, which is a minimum at -1. That's the y value of the vertex. Okay. Let's practice. Now we're going to have one that's flipped over. It's been reflected, so that will help us. We'll change a little bit what we're doing with our increase and decrease, because they're actually going to end up swapping sides. So let's do our intervals of increase and decrease first so we can look at them. So here is my axis of symmetry. Okay. And my vertex in this case is at -1, +4. That's the name of the point for the vertex. -1, +4. If you're having trouble seeing that, you can put this into Desmos and go take a look at it there too. Okay. So I put in my axis of symmetry. My axis of symmetry is at -1. So now I want to start talking about increasing and decreasing. So in this case, the left-hand side of the graph, as I read from left to right, I would be going uphill. This is actually my increase side because it's flipped upside down. And my right side is now my decrease side. So you'll notice they go opposite. Originally we had decrease then increase, but because it's flipped upside down, it goes up and then it goes down. Okay, you think about in a real world situation where a ball is kicked up and then it gets as high as it's going to go and then it starts to come back down. So it's going up for what interval, and then when it's coming back down for what interval. That's really kind of what we're talking about here. So this is our increase side, because we would, if we're going left to right, we'd be going uphill. So that's our increase. That makes this side our decrease. It's going down. Okay, so our interval of increase is the left-hand side. Anything on the left of the axis of symmetry. So any x value that is less than -1. Okay, for decrease, the parabola changes direction right here at your vertex and starts going down. So anything to the right of the axis of symmetry is on the decrease side. So any x value that is greater than -1, and you might see it with underlines on it. I've seen it both ways. So okay, now let's look at some of our other characteristics. This one doesn't ask about end behavior, but anything where they're talking, if the x's are getting bigger, my y values are getting smaller. So this would actually be going to -infinity. As my x values get smaller, my y values are also getting smaller. So that's going to -infinity on that side too, because they're going down and y values go down to -infinity. Okay, do we have a max or a min? Our vertex is right here on top. That makes it a maximum because it's the highest point, and it's a maximum at 4. For range, the entire graph is under the vertex. So that means for range we're talking about less than. And again, it's the y value. The biggest y value is -4, which is what we just said right here. Our y-intercept, we can see it. It's right here. It's at 0, 3. And then our x-intercepts, where the graph crosses or touches the x-axis, there's 2 of them. There is one at -3, 0. And there's one at 1, 0. All right, one last one, and then you can work on your problems. We're in vertex form. That means we can see the vertex very easily. We have the graph. We can see the vertex very easily. I'm going to draw my axis of symmetry in here. Okay, that axis of symmetry is at x equals -3. This left-hand side is the graph is going up. You got to think about if you're walking from left to right, we'd be walking uphill on the left. So this is our increase side. At the vertex, the hill starts to go down, so this is our decrease side. All right, let's see if we can do this without all of the colors, if you're starting to be able to see this or not. So for our interval of increase, increasing is to the left of the axis of symmetry. That's where the graph is going up. So any x value less than -3 is going to be a decrease. Now our interval of decrease, anything to the right of the axis of symmetry is going down. So any x value that's greater than -3 will be on the decrease side. Our axis of symmetry is x equals -3. Okay, let's take a look. What else have we missed? We missed our zeros. Remember, zeros, x-intercepts, solutions all mean the same thing. It all means x-intercept. So our zeros, our x-axis is here. So we're at -5, 0, and -1, 0. For our range, the entire graph is below the vertex. So that means range our y values. So our graph is less than it. Every y value is less than 4. So there's our range. And for our y-intercept, we can see it. It happens right here. If it's not clear, always put your equation into Desmos and go take a look at it. Or you can substitute 0 in for your x value right here. So we would get 0 plus 3 is 3. 3 squared is 9. It's really negative 9 plus 4 is negative 5. We can see this is 1, 2, 3, 4, negative 5. 0, negative 5. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.